Good afternoon, students. So let us begin with the today's class, moving charges and magnetism. Yesterday in the introduction part, we have seen some of the formulas, definitions like what is magnetic field, what is magnetic force. Okay, the expression for the magnetic field due to a charge, the magnetic force due to the conductor. So these all points we have discussed in the last class. Lorentz force anna kuda discuss madidvi ninne. So let us continue with the today's class. So as you have know already, today we are discussing the Biot savart law discuss ಮಾಡ್ತಾ ಇದೀವಿ. ಹೌದಾ? Okay. So what is this Biot savart law? So before going to start with the what is Biot savart law, we need to understand one definition that is called as the current element. So what is current element that we need to understand first? Okay. The current element is nothing but what it is, the small portion. So infinitely very small portion of the conducting wire. Suppose if you consider this as the conducting wire. Okay. So illon small portion anna consider ಮಾಡ್ತೀವಿ to describe the Biot savart law. So ಈ wire ಅಲ್ಲಿ ನೀವು ಇಲ್ಲಿ small portion ಅನ್ನು consider ಮಾಡ್ತಾ ಇದ್ದೀರಾ, that is called as what? That is the current element ಅಂತ ಹೇಳ್ತಾರೆ. Okay, so we are describing the Biot savart law for the current element. So for the entire wire igalla, so just one small portion ing ನಾವು ಇಲ್ಲಿ define ಮಾಡ್ತೀವಿ. Then we integrate the equation to understand that is the complete Biot savart law for the complete wire. Okay, so ನಿಮ್ಗೆ already ಈಗ what is here one blank page slide and we will understand the derivation part. So please copy down the, not derivation actually, ನಿಮಗೆ Biot savart law derivation ಬರಲ್ಲ, just statement ಮತ್ತೆ mathematical formula ಬರುತ್ತೆ. Okay, yes. So here Biot savart law is given for a current carrying wire. In this we will consider one small part, so that is the current element. So this current element, and we consider one point P. This current element and the point P is at a distance of R. So idenide idu yav distance alli ide, this is at a distance of R. Here this current element is making an angle d theta. It is making an angle theta anta ಹೇಳ್ತೀವಿ. And here ನಾವೇನ್ current element ತಗೊಂಡಿದ್ದೀವಿ, ಅದರದ್ದು length ಎಷ್ಟಂತ, it is a very small part. ಹಾಗಾಗಿ ಅದರ length ಅನ್ನ dl ಇಂದ denote ಮಾಡ್ತಾ ಇದೀವಿ. So what we have taken here, students, so this is xy1 conducting wire. So then xy annodide, this xy is one conducting wire. Let I be the current flowing through it. Xy is the current carrying conductor, I be the current through it. Point P is at a distance of R, where we are calculating the magnetic field dB, where we are calculating the magnetic field dB. dl be the, that is current element length of the current element anta ಹೇಳ್ತೀವಿ. Okay, R is the distance. ಹಾಗಾದ್ರೆ Biot savart law ಏನ್ ಡಿಫೈನ್ ಮಾಡುತ್ತೆ? Here the magnetic field at point P, it is directly proportional to the current in the wire. It is directly proportional to the current, and this magnetic field is directly proportional to dl, that is the current element, length of the current element. This magnetic field is directly proportional to the sine of the angle between the point P and the current element. Sine of the angle between the point P and the current element, that is dB is proportional to sine theta. Okay, and one more factor, this dB is inversely proportional to the square of the distance between the point P and the current element. So by combining all the forms here, that is dB is directly proportional to ಯಾವ factor ಇದೆ, I ಇದೆ, dl ಇದೆ, sine theta ಇದೆ, divided by, it is inversely proportional to square of the distance. So dB is proportional to I dl sine theta upon R square. ಮತ್ತೆ ಇಲ್ಲೇನು dB is proportional to, proportionality sign ತೆಗಿಲಿಕ್ಕೆ we introduce a constant, that is mu naught upon 4 pi I dl sine theta upon R square. So what is the formula for the Biot savart law? That is the dB is equal to mu naught upon 4 pi I dl sine theta divided by R square. Yes. So this is the magnetic field for the current carrying conductor, and this is the formula for the Biot-Savart law. ಸೊ ಫಾರ್ಮುಲಾ ನೋಡಿದ್ರಿ. ಹಾಗಾದ್ರೆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನ್ ಬರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ, ಸ್ಟೇಟ್ ಅಂತ ಹೇಳಿದ್ರೆ ಆಕ್ಚುಲಿ ವಿ ಆರ್ ರೈಟಿಂಗ್ ದೀಸ್ 4 ಫ್ಯಾಕ್ಟರ್ಸ್ ಓನ್ಲಿ. ಏನಂತ ಹೇಳ್ತೀವಿ, ದ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ದಟ್ ಇಸ್ the magnitude of the magnetic field. So the magnitude of the magnetic field andre dB, the magnitude of the magnetic field at point P, it is directly proportional to the current. It is directly proportional to the length of the current element and directly proportional to the sine of the angle between the point P and the current element, and it is inversely proportional to the square of the distance between the point P and the current element. Okay. So this is the Biot-Savart law statement as well as the mathematical expression. So please copy down this. So e law anna ನಾವು ಒಂದು current loop ಗೆ apply ಮಾಡ್ತೀವಿ. That is the derivation we are going to see today. Biot-Savart law is applied for the circular loop. There we have the derivation, which is very, very important for 3 mark. Okay. Okay, students. So next what we are going to do, that is Biot-Savart law ಆಯ್ತು. ಹಾಗಾದ್ರೆ Biot-Savart law ಅನ್ನ ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕೆಲವೊಂದ್ಸಲಿ 1 ಮಾರ್ಕ್ ಕೇಳ್ತಾರೆ. So what is the expression for the Biot-Savart law in the vector form is written as, it is dB is equal to mu naught upon 4 pi I into bracket dl cross r divided by r cube. So this is the expression for Biot-Savart law in the vector form. So you can note down this point also. And the derivation which we are doing next is, so the heading is the derive the expression for magnetic field. We are deriving the expression for magnetic field or magnetic field intensity anta kuda helbodu, at any point on the axis on the axis of a circular current loop. Circular current loop using the Biot-Savart law. Okay. So this is the heading for the derivation. Why r cube means, here what is the expression actually, dB is equal to I dl sin theta divided by r square anta bardvi. So here when you are writing in the vector form, what we are doing here, dl cross r we have taken, dl cross r we have taken, and this I we have written as it is. So idu r square iddade enagatte r cube agutte. ನೀವು ಇದು ವೆಕ್ಟರ್ ಫಾರ್ಮ್ ತೆಗಿತಿದ್ದೀರಾ ಅಂತ ಅಂದ್ರೆ ಆವಾಗ ಈ r cancel ಆಗಿ you are getting the previous one itself, and r dl cross r ಅನ್ನ dl sin theta into r ಅಂತ ಬರಿತೀವಿ. ಸೊ ಡಿವೈಡೆಡ್ ಬೈ r ಕ್ಯೂಬ್ ಇದ್ದದ್ದು r ಕ್ಯೂಬ್ r ಅಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ r ಸ್ಕ್ವೇರ್ ಉಳಿಯುತ್ತೆ. This is the vector form. In the first year you will study this. Yes. So dl cross r is nothing but what? dl sin theta into r. So r ಮತ್ತೆ r cube cancel agi we are getting the same equation. Okay. So the students, the next derivation is what? That is the magnetic field at any point on the axis of loop. Yes. So let us begin with the question. Yes. So for that we are considering one current loop. So current carrying circular loop anta ಹೇಳಿದೀವಿ. So current carrying circular loop ಅನ್ನ consider ಮಾಡಿದ್ವಿ. So from the center P magnetic field. So P magnetic and this point P. Okay, and this is making an angle alpha. This is making an angle alpha. So this is Q anta label madi. You can see OPQ is a right angle triangle. So DL is the current element. And this is the R. Okay. I think PPT is not visible. Just 1 minute. I'm sharing it. Yes. So here we are taking the current loop. So this is the radius of the loop R, O, and this is the P point, and from here to here, this we have the angle alpha. This is Q. DL is the current element, and this is R, and this is X. Okay. So now we are considering the resultant of this magnetic field along this direction. So the magnetic field, I'll take it as dB, because the magnetic field according to Biot law for the current element we apply ಹಾಗಾದ್ರೆ ಅದೇನಾಗುತ್ತೆ dB ಅಂತ ಇರುತ್ತೆ. So therefore now this dB can be resolved into two components, students. The dB can be resolved into two components. So what are the components? Now vector resolutions first year al ಕಲಿತೀವಿ. This dB two components. One is dB cos theta ಅಂತ ಆಗತ್ತೆ. Okay, so ಇಲ್ಲಿ angle alpha ತಗೊಂಡಿದ್ದೀವಿ, therefore ಇದು ಹಾಗಾದ್ರೆ cos theta ಬದಲಾಗಿ this is cos alpha. Okay, so this is along x-axis. This is along x-axis. We have dB cos alpha, and this is what? dB sin alpha. Okay, so if you are taking it for the y-axis, idenayitu x-axis component resolve ಮಾಡಿದ್ವಿ, y-axis component resolve ಮಾಡಿದ್ದೆ idenagatte, this becomes dB sin alpha and dB cos alpha will be along the same direction. ನಿಮಗೆ first year vectors ಸರಿಯಾಗಿ ಗೊತ್ತಿದ್ರೆ ಇದು ಅರ್ಥ ಆಗತ್ತೆ how we resolved it anta. Okay, So this is the resolving the dB along the two components, that is along the x-axis and along the y-axis. So we can take here also this one. ಹಾಗಾದ್ರೆ ಇದೇನಾಯ್ತು dB cos alpha, dB cos sin alpha, dB cos alpha, ಮತ್ತೆ ಇದು dB cos alpha, dB sin alpha. Okay. So therefore, so let us begin with the derivation, students. Here first, the magnetic field. I'll tell you now ಏನು ಮಾಡ್ಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಇದೀವಿ ಅಂತ. We are calculating the magnetic field for the current carrying loop. ಹಾಗಾದ್ರೆ magnetic field ನಮಗೆ B ಅಂತ ಬೇಕು. ನಾನು ನಿಮಗೆ in the beginning only ಹೇಳಿದೆ, that is directly we cannot calculate the magnetic field for the entire loop. So full loop ಗೆ ಬರಲ್ಲ, just one current element, small portion element ಗೆ consider ಮಾಡ್ತಾ ಇದೀವಿ. ಹಾಗಾದ್ರೆ full ನಮಗೆ ಇದು ಬೇಕಂತ ಅಂದ್ರೆ, suppose if we want the magnetic field for the entire loop, what I need to do, that is I need to take the summation of the dB. I need to go for summation of dB. Yes, understood why we are taking the summation? Because the Biot-Savart law is applicable only for the small current element. ಹಾಗಾದ್ರೆ full current loop ಗೆ ಬೇಕಾದ್ರೆ we need to take the summation of dB. So it is not only summation of dB. Here one more point it will come. ಇಲ್ಲಿ ನೋಡಿ dB ಬರೀ dB ಅಷ್ಟೇ ಇಲ್ಲ, we are resolving it into two components, there is sin theta and the cos theta component. ಹೌದಾ? So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, if you see the dB sin alpha ಮತ್ತೆ dB sin alpha ಎರಡು opposite direction ಇದೆ. You agree this point? Both dB sin alphas are in the opposite direction.
Yes, ma'am.
So ಇದೇನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇದ್ರದ್ದು magnitude equal ಇರುತ್ತೆ. The magnitude of this dB sin alpha will be equal, but they are opposite in direction. Therefore, this component will get cancelled. Why it will get cancelled? Because they have the same magnitude but opposite direction. Therefore, the sin alpha component will get cancelled. But if you see cos alpha, that is in the same direction for both the vectors. ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ ನಾವೇನ್ ತಗೊಳ್ತೀವಿ ಅಂದ್ರೆ summation of dB cos alpha ಅಂತ ಬರ್ತೀವಿ. This is equation 1. So in this equation 1, we need to substitute our dB value and cos alpha value. So let us substitute. I hope you understood why this equation 1 will come. From here, the derivation will start. So what you need to do, the magnetic field dB is resolved into two components along x and y axis. Here the y components, that is sin alpha component, will get vanished. dB, x components will be added up. So therefore the magnetic field is given by dB cos alpha. Now let me write the value of dB now first. That is equal to summation of. So according to Biot-Savart, it is given by mu naught upon 4 pi I dl upon r square. It is nothing but mu naught upon 4 pi I dl upon r square. So cos alpha, keep it as it is. Keep cos alpha as it is. Okay. So now here summation is what? We need to take the constant terms outside. It is like integration itself. So integration ಮಾಡ್ಬೇಕಾದ್ರೆ constant terms ಅನ್ನ ಹೊರಗಡೆ ತಗೊಳ್ತೀರಾ. So mu naught upon 4 pi constant ಇದೆ, ಹೊರಗಡೆ ಬರೀರಿ. Current in the element, it is constant, and whatever the distance is there, that is also constant. So I r square ಹೊರಗಡೆ ಬರುತ್ತೆ. Cos alpha is also outside. The remaining is what? That is summation of only dl. It is summation of dl. Okay. So this is my equation 2. So before going to simplify summation of dl, let me write what is cos alpha from the figure. So from the figure, cos alpha is equal to, you can see POQ is a right angle triangle ಅಂತ ಹೇಳಿದೆ ನಾನು. ಹಾಗಾದ್ರೆ cos alpha is equal to ಏನಾಗುತ್ತೆ? This cos alpha, it becomes r by small r. You can see here. Already we have written that. ಇಲ್ಲಿ ನೋಡಿ. So hypotenuse is small. So from the right angle triangle POQ, the cos alpha is r divided by r. It is r divided by r. Okay. So therefore, let us substitute the value now. which is equal to mu naught upon 4 pi I upon r square. It is I upon r square. Cos alpha enagatte, it is r divided by r. It is r divided by r. Okay. Into. So whatever this the summation of dl is there, the summation of dl is nothing but what? Circumference of the circular loop. So what is circumference of the circular loop? Formula. Any idea? In maths you will learn this. The circumference of the circular loop is given by, it is 2 pi LC, students. It is 2 pi R, not 2 pi L. It is 2 pi R. The circumference of the circular loop is given by, that is summation of DL anta now define ಮಾಡ್ತೀವಿ. So that is given by 2 pi R. It is 2 pi R. So B is equal to, ನಿಮ್ದಿಗೆ ಏನು ಬಂದಿದೆ? B is equal to mu naught upon 4 pi I divided by R square, R by R into 2 pi R. So further, if I simplify this, it becomes mu naught upon 4 pi I R square into 2 pi divided by R square into R is R cube. It is R cube. Okay. So see, if any doubt is there in the steps, you can ask. Equation 1, 2, 3. So last one step is remaining up to equation 3. If you have any doubt, you can ask, students. So now ಏನು ಮಾಡಿದ್ದೀವಿ, as I told you, Biot-Savart law is applicable only for the current element. So entire looping find out ಮಾಡಬೇಕಾದ್ರೆ we need to take the summation for that. So summation of dB cos alpha ಆಗತ್ತೆ. So dB value from the Biot-Savart law mu naught upon 4 pi I dl by r square. Cos alpha ಅದೇ ರೀತಿಯಾಗಿದೆ. I told you why it is cos alpha. So constant terms, take it outside. We have only summation of dl. So from the right angle triangle POQ, cos alpha will be r by r. Then what is summation of dl? It is 2 pi r. So simplify, you will get equation 3. One last step is remaining. So if this is completed, writing part, I can tell you the last part.
Yes, ma'am.
Okay. So see here, from the right angle triangle, from the figure, that is r square is equal to. So according to the Pythagoras theorem, I can write r square is equal to r square plus x square. See, you will note both. From the right angle triangle, r square is equal to, it is r square plus x square. So suppose if I want only for r, this implies r is equal to enagatte r square plus x square to the power of 1 by 2. To the power of 1 by 2. ಹಾಗಾದ್ರೆ r cube is equal to ಏನಂತ ಬರಿಬಹುದು? We can write it as r square plus x square raised to 3 divided by 2. r square plus x square raised to 3 divided by 2. Yes, r cube value is clear to everyone?
Yes, ma'am.
Yes. Okay. So therefore, you can substitute the value of r cube there, and which completes the derivation. So see, so it is mu naught upon 4 pi 2 pi, just rearrangement ಮಾಡಿದೀನಿ ನಾನು ಇಲ್ಲಿ. That is mu naught upon 2 pi, as it is 2 pi we have, sorry, mu naught upon 4 pi 2 pi ಅಲ್ಲೇ ಇದೆ. then I r square divided by r cube place ಅಲ್ಲಿ we have substituted r square plus x square raised to 3 divided by 2. Okay, here you may ask me 2 pi cancel ಮಾಡ್ಬೋದಾ ಅಂತ. ಮಾಡ್ಬೋದು, ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗತ್ತೆ, ನಿಮ್ಗೆ ನ್ಯೂಮರಿಕಲ್ಸ್ ಈಗಲೇ ಕ್ವಶನ್ ಮೇಲೆ ಬಂದ್ರೆ ಈ ಫಾರ್ಮುಲಾ ಮೇಲೆ already you know what is mu naught upon 4 pi. Can anyone tell me what is the value of mu naught upon 4 pi? What is mu naught upon 4 pi? It is 10 to the power of minus 7 c. ನಾನು ನಿಮಗೆ ನಿನ್ನೆ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ. mu naught upon 4 pi is written as 10 raised to minus 7. ಸೊ ಇದು ನಮಗೆ ಆಲ್ರೆಡಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಗೊತ್ತಿದೆ. ಸಪೋಸ್ ನೀವು ಇದು 2 pi ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ ಇದನ್ನ mu naught upon 2 ಅಂತ ಬರದ್ರಿ ಅಂದ್ರೆ ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ, mu naught ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ, ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡ್ಬೇಕಾಗತ್ತೆ. The simplification will be lengthy because it is in the decimal and the power. So instead of that, ನೀವು ಇದೇ ರೀತಿಯಾಗಿ ಇಟ್ರೆ ಏನ್ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಅಲ್ಲಿ. You can keep it as it is so that you can take directly mu naught upon 4 pi is equal to 10 raised to minus 7 into 2 into pi value is 3.142 and r value ಏನ್ ಕೊಡ್ತಾರೆ ನೀವು ಅದನ್ನ substitute ಮಾಡಬಹುದು. Yes, the derivation is clear to everyone. So this is the important derivation from this lesson. 3 marks ಅಲ್ಲಿ ಬರುತ್ತೆ. Derive the expression. Actually previous 3 ಅಂದ್ರೆ ನಿಮ್ಗೆ syllabus reduce ಆಗಿದೆ. Before that they used to ask the same derivation for the 5 mark. So see, if any doubt is there, you can ask. So here we have some of the shortcut formulas. Copy down. Once you copy down, we will go for the some formulas again. Completed everyone?
Yes, ma'am.
So the next point we have, that is the expression, not derivation. Just one small formula, the shortcut formula anta tagolbodu for the CET exam and all. That is for the expression for the magnetic field at the center of the circular loop. At the center of the circular loop, it is given by B is equal to, it is B is equal to mu naught into I divided by 2R. Mu naught into I divided by 2R. This is the expression for the magnetic field due to the at the center of the circular loop. Okay, at the center of the circular loop. So ನೀವು ಸೆಂಟರ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ನೀವು ಈಗೇನ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಬರ್ದ್ರಿ ಅಲ್ಲಿ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ, 0 ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಎಕ್ಸ್ ಟರ್ಮ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿದೀವಿ. 2 pi ವ್ಯಾಲ್ಯೂ ಕೂಡ 2 pi cut ಮಾಡಿ, we are left with what? Only mu naught upon r. So further if you simplify, that is we are getting mu naught into I divided by 2r. Suppose if there are n number of turns for the loop, then you can write this expression as what? Mu naught into n into I divided by 2r. Mu naught into n into I divided by 2r. Okay. So this is the expression for the magnetic field at the center of the loop and at the center of the current loop with n number of turns. The next one we are going to discuss, that is Ampere's circuital law. So what is Ampere's circuital law? See here, the Ampere's circuital law is given by Ampere's circuital law. So what is this Ampere circuital law tells? The line integral. So maths alli namge line integral anta one concept barutte. So the line integral of the magnetic field around any closed path is equal to mu naught times the total current in the path. So that is the line integral of magnetic field around any closed path in the free space is equal to mu naught times the net current enclosed by the path. So that is BDL is equal to mu naught into I. Yes. So the derivation illa students, just Ampere's law statement ಮತ್ತೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಮಾತ್ರ ಇದೆ. ಸೊ ನಿಮ್ಗೆ ನ್ಯೂಮರಿಕಲ್ ಬರುತ್ತೆ ಇದ್ರ ಮೇಲೆ 2 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ. BDL is equal to mu naught into I. So mu naught is permeability, I is the current, DL again the current element, and B is the magnetic field. So after this we have the solenoid and the toroid, but the toroid part ನಿನ್ನೆನೆ ಹೇಳಿದೆ ನಿಮಗೆ toroid delete ಆಗಿದೆ. So only solenoid ಅನ್ನ ನಾವು discuss ಮಾಡ್ತೀವಿ. So before going for the solenoid, we have one more small expression. So let us derive that based on the Ampere's circuital law. Okay. So based on the Ampere's circuital law, we have one small derivation. Let us expression is expression for the magnetic field due to a straight current carrying wire applying the Ampere's law. So by using the Ampere's law, we will do this. So for that, we have one circular loop there. So in the circular loop, we have a current carrying conductor. So XY is the long straight wire in which let I be the current flowing through this. So point P be the point where we are calculating the magnetic field. Okay. So the current element is DL. DL is the current element. And ಮತ್ತಿಲ್ಲಿ ನಾವು ಲೂಪ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ. ನಿಮ್ಗೆ ಆಲ್ರೆಡಿ ಗಾಸ್ ಲಾ ಮತ್ತೆ ಗಾಸಿಯನ್ ಸರ್ಫೇಸ್ ಗೊತ್ತಿದೆ. ಗಾಸ್ ಲಾ is applied for the Gaussian surfaces. So similarly Ampere's law is applied for the Ampere in loop ಅಂತ ಹೇಳ್ತಾರೆ. ಅಂದ್ರೆ wire ಇದೆ, at point P we are calculating the magnetic field. So for this we are considering one Ampere loop to apply the Ampere's law. This is the aim of the derivation. So very small derivation. Let us see how we are going to do it. So see here. That is, from the Ampere's law, we have the current element, that is the line integral of B dl is equal to mu naught into I. This is our equation 1. This is our equation 1. Okay. So here we have B dot dl. So this B dot dl can be written as B dl cos theta. It is written as B dl cos theta. B dot dl can be written as B dl cos theta. This is our equation 1 and equation 2. Okay, but cos theta, here the angle is 0. Here the angle is 0. Therefore, cos 0 is equal to 1 anta agate. Therefore, it becomes just B dl, the line integral of B dl anta tagoltivi. The line integral will be remaining as it is. The line integral of B dl agate. Dot product hoytu illi. Aita. So, next step what we are going to do is, that is equal to B of summation of dl. B of summation of dl. So what is summation of dl? It is nothing but the circumference of the loop. So the circumference of the loop, already in the previous derivation we have seen, it is 2 pi r. The circumference of the loop is taken as what? 2 pi r. So it yellinda bandide from the B dot dl. This is equation 2. Sorry, 3. Compare equation 1 and 3. So if you compare equation 1 and 3, illu kuda line integral of B dot dl, illu kuda line integral of B dot dl. So ಎರಡು same ಇರೋದ್ರಿಂದ we can equate the RHS side. So if I equate the RHS side, it will be B into 2 pi r is equal to mu naught into I. B into 2 pi r is equal to mu naught into I. ಹಾಗಾದ್ರೆ B is equal to ಏನು ಬರುತ್ತೆ? Mu naught into I divided by 2 pi r. Mu naught upon I divided by 2 pi r. So this is the expression for the magnetic field due to a straight current carrying wire. Yes. So very simple. First step, according to Ampere's law, you are writing the first equation. Second equation, what you are writing, we also know that B dot dl can be written as B dl cos theta. But il angle 0 irodrinda B dot dl iddadu B dl agate. And that summation, if I applied for the dl, it is 2 pi r. So now equation 1 and 3 are equal. So if I equate equation 1 and 3, nange magnetic field sigatte for the wire XY. So ಈ wire XY ಗೆ ನಂಗೆ magnetic field ಬಂತೀಗ B is equal to mu naught into I divided by 2 pi r. Yes, students, is it clear to everyone?
Yes, ma'am.
Okay. So in the next class, we are deriving the other derivations for the solenoid and the parallel current carrying conductor. ಇಲ್ಲಿ ಬರೀ single ಇತ್ತು 2 wires ಇದ್ದಾಗ ಏನ್ ಬರುತ್ತೆ ಅಂತ. In the next class, we will continue. Thank you, everyone.